Section 6.6, using proportionality theorems. Theorem 6.4 says if a line is parallel to one side of a triangle and intersects the other two sides, then it divides the two sides proportionally. So in other words, if TU is parallel to QS, then RT over QT is equal to RU over US. So you can see this. This would mean 6 over 2 would equal 9 over 3. And we know that that's true because 3 equals 3. Notice that you can also say RT over RU, 6 over 9, equals 2 over 3. 2 over 3, 2/3. So it'll work either way. You can use your proportionality statements to switch them around. So in this case, finding the length of a segment, we're told that QS is parallel to UT, and RS is 4, and ST is 6, and QU is 9. What's the length of RQ? So there are two ways you can set up this proportion. You can either say RQ over 9 equals 4 over 6, and so of course that simplifies to 2/3. And since 3 times 9 is 3 times 3 is 9, then 2 times 3 is 6. So RQ would equal 6. We could also set this up as RQ over 4 equals 9 over 6, and divide these both by 3 and get 3 over 2, and multiply 2 times 2 to get 4, and 3 times 2 to get 6. Again, RQ equals 6. Okay? So once again, you can go top to bottom, or you can go side to side equals side to side. Either way will work. So find the length of YZ here. And what I'm going to do is let you, if you'd like to try this problem, you can pause it and do it. Otherwise, we'll move on. The converse also is true. If the two sides are proportional segments, then the parallel line, then the line is parallel, okay? So in other words, if RT over TQ is equal to RU over US, then the lines are parallel. So if A over B equals C over D, in this case, then the lines are parallel. So let's try one. Well, first of all, let's consider a triangular piece of wood. If the length from A to D is 15 centimeters, and the length of B to D is 45 centimeters, how can you make one measurement and calculate where to place point E exactly so that DE is parallel to AC? So here's what I want you to think about. We know that 45 over 15 would have to equal BE over EC, wherever E is going to be. We also know with our proportionality postulates that 45 plus 15 over 15 would equal BE plus EC over EC. So in other words, the whole length of one side over the short piece will equal the whole length of the other side over the short piece. So if we just measured the whole length right here, we would be able to tell from the proportion, we would be able to solve for EC and know exactly where to put EC. Okay? So, in other words, we would make one measurement, and then we would be able to calculate where to place point E so that DE would be parallel to EC. So let's say we measured BC, and we found out that it was 80 centimeters long. So if it's 80, then we would know that 60 over 15 equals 80 over EC. And by solving this, knowing of course that this is 4 to 1, then we would know that 4 times 80 times 20 is 80, so EC must go at 20. So I would plot point E, and I would put it at 20, which would make BE 60, and that would be in proportion, 3 to 1, 3 to 1. There you go. So on this shoe rack, AB is 33, so I'm just going to draw this triangle off to the side over here. AB is 33, I'm sorry. And BC is 27. CD is 44. And DE is 25. Explain how you know that the gray shelf is not parallel to the floor. Simple. We do 27 over 33, and we ask ourselves, is it equal to 44 over 25? And so that's 1/3. Is it equal to 44 25ths? No, because 44 25ths is more than 1 anyway. So it's not true. So they're not parallel. Now we can tell this pretty quickly by looking at this and knowing, since this segment is larger than this segment, then this segment here, DE, would have to be larger than CD. And so just at a glance we can tell that it wouldn't be parallel. So here's a problem for you to do. If you want to take a minute, you can pause this and see if you can prove that it's true or false. Theorem 6.6. If 3 parallel lines intersect 2 transversals, then they divide the transversals proportionally. So I want you to think about something. In the previous examples, we had a triangle with 2 sides that are parallel, 2 pieces that are parallel. And if you think about the point there, I could also draw a line that's parallel through that. There is a line that can be drawn parallel to this line that goes through that point. Since that's true, imagine that I opened up the triangle so that the segment that's at the top doesn't touch. Okay? These lines would still be parallel. This line here would still be parallel. And these sides, I'll just call them A and B, and C and D, would still be in proportion. They're in proportion now, and they would stay in proportion. We would just be creating some further segments up here, which, of course, if there was a parallel line, yada, 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 those could also be in proportion. So, although this theorem says if 3 parallel lines intersect 2 transversals, then they're in proportion, it really is an infinite number of parallel lines intersect an infinite number of transversals, then all the sides would be in proportion, all the segments would be in proportion. So we're going to do an example right now so you can see what that means. So we have this situation with South Main Street, 2nd Street, Main Street. Okay, in the diagram, all the measurements are accurate. They want you to find the distance HF between Main Street and South Main Street. So once again, we've got proportions. 120 over HG equals 150 over 300. Well, I want to find HF, and so I'm going to have to look at this a little bit differently here for just a second.